Hi, welcome to this lesson on number patterns, geometric sequences. We'll be doing the problem on solving a geometric sequence problem, question 5. So we're given that a certain virus infects people each day, and that this virus can be modeled using this exponential equation, Tn equals 2 times 3 to the power n minus 1, where n is represented by the number of days that have passed. So find how many people are infected on the 4th day, and find out which day the virus will infect 39,366 people. All right. So there's two parts of this question. So first, let's do a little bit of an interpretation. All right. Let's see what happens on the first day, t sub 1. So if I plug in n equals 1 into this equation, I get 2 times 3 to the power 1 minus 1. That's going to be 2 times 3 to the power 0. 3 to the power 0 is just 1. So I get 2. So on the first day, this virus has infected 2 people. Okay. What about T2? So I plug in 2 here, where n is, and I get 2 times 3 to the power 1, which is 2 times 3, which is 6. So, on the second day, 6 people now get infected. These are 6 new people, different from the 2 people before. And I can keep checking for T3, T4, and so on, how many new people get affected by this virus each day. But we want to know T4 on the 4th day. So if we plug in there, for n equals 4, I get 2 times 3 cubed. Well, 3 cubed is 27, and 2 times 27 is 54. So on the 4th day, by the end of the 4th day, this virus will have infected 54 new people. So you can see why viruses are usually modeled after exponential equations, because they grow rather quickly in a short amount of time. Now we want to find out which day the virus will have infected 39,366 people. So essentially, we're looking for that nth day, such that this equation, this general formula, will give you the output of 39,366. So this is the equation that we are trying to solve. It's an exponential equation, so one of two things needs to happen. We need to either match the bases to equate the exponents, or we can use logarithms. Okay? Now, matching bases is the most common technique, and we've been doing a lot of problem solving on that, but in reality, the numbers aren't always very nice, like these nice whole numbers I've given you here. In reality, the numbers can usually be like decimals, some heavy looking fractions. So the more preferred method we should be using is logarithms. So I'm going to use the logarithm approach here to show how we solve this exponential equation. First things first, I'm going to divide both sides by 2 to get rid of that number there. So I get 39,366 divided by 2, which is 19,683. Okay, then I'm going to say, well, this is 3 to the power n minus 1 equals to this big number here. So to get the exponent by itself, I use logarithms. So this is the base, this is the exponent, and this is the value output that we are looking for. So remember, we take the log of the base on both sides. So log base 3 of 3 to the power n minus 1 is equal to log base 3 of this big number here, 19,683. Taking log base 3 of this 3 allows you to move the exponent down. So you just have the exponent, n minus 1, equals the log of base 3, 19,683. Lastly, let's get rid of that negative 1. I'll add 1 to both sides. So it's going to be 1 plus log base 3 of 19,683. But let's go ahead and use our calculators to check what is that value. So first of all, where did I get that 19,000 from? So what we do is we took that 39,366 and we divided it by 2. That's where I get the 19,683. Then I want to say log, and you need to use the log where it has the little base at the bottom. So in your base you're going to put 3. And inside the input, you're going to put 19,683. And if you press equals on that, look at that nice number, 9. And then we need to add 1 to that, which is 10. So we get n equals 10. So on which day? It'll be the 10th day. Let's verify this. Let's plug 10 back into that general formula, this one here on the top. So t sub 10 equals 2 times 3 to the power 10 minus 1, which is 2 times 3 to the power 9. Well, let's use our calculators to check that. So I'm going to say 2, open brackets, 3, all raised to the power 9. And there we get it, 39,366. Now look how fast that virus is growing. Already on the 10th day, not even halfway through a calendar month, and this virus has nearly infected almost 40,000 people, almost, just after 10 days. So that's why when you hear on the news, when viruses grow at an exponential rate, this is what is happening. This is the formula that they are using to give you the output of those numbers every day of the people that are infected. Okay, do another problem. I'll see you in the next one.